Trigonometry is a branch of mathematics where we study the relationship between angles and sides in right-angled triangles. In this video we will look at cosine, sine and tangent, which are ways to express these relationships. But first we'll go through some necessary concepts and definitions. First, let's quickly introduce a right-angled triangle. A right-angled triangle is a triangle where one of the angles is 90 degrees, which we indicate with a square at the angle. We call the sides that form the 90-degree angle the legs, in this case the sides A and B. The last side C is called the hypotenuse of the triangle. In relation to angle theta, we call side B the opposite leg to this angle. Side A is called adjacent leg, which is a part of the angle theta. Remember that theta is a Greek letter and it only represents a magnitude. For example, angle theta could be 40 degrees in this example. Let's now call the other angle in the triangle alpha, which could be, for example, 50 degrees. In this case, A would be the opposite leg to angle alpha, and B would be the adjacent leg. Now that we have a better understanding of what a right angle triangle is, we can move on to define two important concepts in trigonometry, sine and cosine. We define sine as follows. Sine of an angle theta equals the opposite leg of theta divided by the hypotenuse. And we define cosine as cosine of theta equals the adjacent leg of theta divided by the hypotenuse. This means that sine tells us the relationship between the opposite leg and the hypotenuse for a given angle theta, and cosine tells us the relationship between the adjacent leg and the hypotenuse for a given angle theta. Let us now draw a right angle triangle and look at sine and cosine for an angle theta. Here we find that sine of theta is b divided by c, since b is the opposite leg to theta and c is the hypotenuse. We can also find that the cosine of theta is a divided by c, since a is the adjacent leg and c is the hypotenuse. Let us now look at the other angle in the right angle triangle, alpha. In this case, we have that the side A is the opposite leg, so we get that sine of alpha is A divided by C. We also have that B is the adjacent leg of the angle alpha, and therefore we get that cosine of alpha is B divided by C. So these concepts will be a lot easier to understand after looking at a few examples. But the main idea is that if we have an angle alpha or an angle theta, in a right angle triangle, we can say something about the relationship between the sides of the triangle. In this example, we have a right angle triangle where one of the angles is 60 degrees. The hypotenuse is 6 units long, and the adjacent leg to the angle is 3 units long. In this case, we find that cosine of 60 degrees is 3 divided by 6. In other words, cosine of 60 degrees equals 1/2. This simply means that if we have a right angle triangle with an angle of 60 degrees, we know that the hypotenuse is twice as long as the adjacent leg to the angle. That is, if the hypotenuse is 1 unit long, the adjacent leg will be 0.5 units long, or half the length of the hypotenuse. If we now increase the size of the triangle, this relationship still holds. For example, if the hypotenuse is 8 long, the adjacent leg equals 4. In this example, we are looking at a right angle triangle with a 35-degree angle. One side is 3 units long and the hypotenuse is 3.66245 units long. We find that the cosine of 35 degrees is 0.8192. This means that in a right angle triangle with a 35-degree angle, if the hypotenuse is 1 unit long, the adjacent leg is 0.8192 units long. And this relationship is always true. So if the hypotenuse is 10 long, the adjacent leg is 8.192 long. Now that we have this information, we can use it to find unknown sides in this right angle triangle. In this example, one of the angles in the triangle is 35 degrees, the hypotenuse is equal to 2, and the adjacent side to the angle is unknown. We can now find this unknown by using what we know about the relationship between these two sides when the angle is 35 degrees. Let's set up an equation. As we already know, the cosine of 35 degrees becomes x divided by 2. which we know from earlier should be equal to 0.8192. We therefore get the following equation. By multiplying both sides by 2, we quickly get the answer we are looking for, namely that x must be equal to 1.6384. In this case, we look at a right-angled triangle with a 45-degree angle, where the length of the opposite leg to this angle is the square root of 2, and the hypotenuse is 2 units long. We can find sine of 45 degrees by dividing the length of the opposite leg by the hypotenuse, giving us sine of 45 degrees equals the square root of 2 divided by 2. This means that in the case where the hypotenuse is 1 long, the opposite leg is the square root of 2 divided by 2. And in the case where we look at the same triangle but with hypotenuse 5, the opposite leg will also be 5 times as long. In this example, we have a right-angled triangle with one of the angles being 14 degrees. The opposite leg to this angle is 1 unit long, and the hypotenuse is unknown. We can find the length of the hypotenuse using sine. First, we find that sine of 14 degrees equals 0.242, which tells us that the opposite leg is 0.242 units long if the hypotenuse is 1 unit long. Using this information, we set up the following equation, and solving for x, we find the length of the hypotenuse. We're now going to look at a final definition called tangent. But first, let's repeat the definitions we have learned. Sine of an angle is defined as the opposite leg divided by the hypotenuse, and cosine of an angle is defined as adjacent leg divided by the hypotenuse. Tangent is simply defined as sine of an angle divided by the cosine of the same angle. Using the definition of sine and cosine, we can simplify the definition of tangent to get b divided by a. In other words, the tangent of an angle is defined as the opposite leg divided by the adjacent leg, which is the ratio between the legs. In this example, we have a right-angled triangle with one of the angles being 30 degrees. The opposite leg is 3 units long and the adjacent leg is unknown. To find the unknown leg, we use the definition of tangent and set up the following equation. First, we find that tangent of 30 degrees equals 0.577. We solve for the adjacent leg and find that it is 5.2 units long. If this video was helpful, please like and subscribe.